All right, I just want to do a quick explanation of the penguin problem for you. Penguin population on an island is modeled by a differentiable function p of time, where p of t is the number of penguins and t is measured in years from 0 to 40. There are 100,000 penguins, that's a lot of penguins, on the island at time t equals 0. The birth rate for the penguins is modeled by b of t, penguins per year, and the death rate is modeled by d of t, penguins per year. So this is one of those rate in, rate out type questions. Be careful so that you understand what you actually have here. We have P of t, which is the penguin population. So that whole rate in, rate out is the rate of change of the penguin population. So rate of change is derivative, so P prime of t is B of t minus D of t. And I think that's the problem that some of you had. Some of you said this was P of t, and that's not true. That's the rate of change. When you see words like rate, birth rate, death rate, we're talking about the derivative. So the derivative of the population is the rate in minus the rate out. So part A, what is the rate of change of the penguin population at times t equals 0? We're looking at rate of change of the population. We're looking for P prime. So P prime of 0 is B of 0 minus D of 0. So B of 0 minus D of 0. And the birth rate is just 1,000 e to the 0 minus the death rate, which is 250 b to the 0. So 1,000 minus 250 is going to get you 750. Now notice it doesn't ask for the units. So on the AP, don't give them. If you do and you give it wrong, you lose points. So don't give them more information than they ask for. If you did do it, it should have been penguins per year. But you don't need to list that unless they ask for units. Okay, part B. The nearest whole number, what is the penguin population on the island at time 40? We want P of 40. Now we don't have an equation for population. We only have an equation for the derivative. So when I want the original function and I have the derivative, what do? Integral, that's the fundamental theorem. And we also know that there are 100,000 penguins on the island at time 0. So we know that P of 0 equals 100,000. So this is one of those questions where you take the integral from something you know to something you want to find of the birth rate, B of t, minus the death rate, D of t. Don't forget your dt. If you did forget dt, I took off a point just like the AP would. And that equals the population at 40 minus the population at 0. So again, we know this is 100,000. And I know that I can plug right into the calculator. So if I do math 9 from 0 to 40, I just speed things up. I already put the birth rate minus the death rate in y1 because I know I'd want to use that a lot. So I can just go here now and then go vars, y vars, function y1, dx. Okay, so this number over here is 33,057, dot, dot, dot. So then I just need to add this 100,000 over. So take that number plus 100,000. And I get to my population, which is said to the nearest whole number. So here I am going to round it. 133,058 llamas. Or, sorry, penguins. Okay. Now for part C, there's two ways to do it. To the nearest whole number, what's the average rate of change of the penguin population on the island between 0 and 40? So first off, average rate of change means slope. Slope of what? Slope of the penguin population. So slope of the penguin population literally means slope, change in y over change in x, over an interval between 0 and 40 of the population. So that'd be the population at 40 minus the population at 0, all over 40 minus 0. Okay, well, the population of 40 is what we just found, 133,058, minus the population at 0, which is 100,000, all over 40. And I can plug that in. 133,058 minus 100,000, hit enter, and divide by 40. And I end up with, the nearest whole number would be 826, because it did ask for the nearest whole number again. And again, I don't think it said units, so don't give them. If you had to, it would be penguins per year, because it's still a rate, the y value over the x value. Okay, now I said there was two ways to do this one. When you see the word average, if you have the equation, the average of what? The average of the rate of change of the penguin population. I do have an equation for the rate of change of the penguin population. It's b of t minus d of t. So if I have an equation for the average, I could say the 1 over b minus a thing. So b and a are 40 and 0, so 1 over 40 times the integral from 0 to 40, the average of the rate of change. So the average of b of t minus d of t. Don't forget your dt. If I type this in, oops, it'll be 1 over 40 times math 9 from 0 to 40. Again, b of t minus d of t I have saved in y1, so vars, y vars, function y1, dx, and look, same number, 826. So I think that word average rate of change always throws people off. That shows you the two different ways to do it. If you think of it as average of a function, the function is the rate of change of penguins, I can do 1 over b minus a. If you think of it as average rate of change of a function, then it's the slope value of a function. Okay, two options. Last one. So nearest whole number, find the absolute minimum penguin population and absolute maximum penguin population between 0 and 40. Show analysis that leads to your answer. Okay, when I want absolute max and absolute min of the quantity I have an equation for, I start with the equation. I want the absolute max and min of p of t. I got to find the critical values. So you set p prime of t equal to 0. But again, p prime is just b of t minus d of t. I want to know where that's equal to 0. So I've already got b of t minus d of t in y1. Let's make y2 equal 0. We want to find it specifically on my interval from 0 to 40. The y min and y max can just be negative 10 to 10 because I'm looking for where it hits 0 anyways. And I'm going to be looking for where that graph crosses the x-axis. That's going to find my critical values. And that's the first step. There it is. And then y2 equals 0 comes across in the red line. Second calc intersect. First curve, second curve guess. 34.657 equals t. That's a critical value. So the absolute max or min could be there. To find out exactly where, though, we have to make a table. And we do the critical value we just found, 34.657, and we also do the endpoints, 0 and 40. Now the population at 0, I already know, that was 100,000. Population at 40, we found in part B, that's 133,058. So all that's left is this critical value, and if I want to find that, I'm going to do it exactly like I did part B. I'm going to go from 0 to that critical value. So the integral from 0 to 34.657 of b of t minus d of t dt. Again, that equals the population at 34.657, which is what I'm looking for, minus the population at 0. Okay, so one more time, I need to do math 9. This time going from 0 to 34.657. B of t minus d of t. You can see why I put that in y1 now, so I don't have to rewrite that every time. Dx gives me that number, but then add over the 100,000, add over that p of 0 value. So 139,167. And then just make sure you answer the question. They asked for the absolute minimum population and the absolute maximum population. They want these values. So the maximum looks like it's at that critical value, 139,167. The minimum is at t of 0, 100,000. I like that some of you justified it because it's the highest and lowest values when evaluated at critical points and endpoints, but it didn't ask you to justify. It just asked you to show the analysis. I did that with all my work. All right, so hopefully that explained the penguin problem if you were confused at all. If you still have any questions, feel free to reach out and ask.